Next we have angle, and I know that you guys have a little space provided to actually draw one out, so kind of draw it in this or to the right of it, or if you have space in your margins, go ahead and do that there. But an angle are two rays, or formed by two rays, that has the same endpoint called the vertex. So let's draw that. So here's our point, okay, or our endpoint, and there are two rays that are coming out of it. So we know that a ray is a line that starts from a point and goes on forever in a certain direction. So here's our point, here's our one ray, and then so since an angle is formed by two rays from the same endpoint, we have to draw another ray. Okay, so this point right here is called the vertex, not an endpoint anymore. So the fact that we have one line going from one point and a different line starting from the same point, that's called the vertex. So highlighting our vertex right there, and there we go. So how do we name angles? So first we actually can call the angle by its vertex. So let's draw an angle. So we have our vertex and then we have our two rays. So then if we have to name the angle or identify the angle out loud to somebody, or if you're describing what specific angle you're talking about, you can call it by its vertex. So if we know that the vertex has a label M or a name of it, we can call this angle M. And this is how we write or identify an angle that you see on paper, angle M. So you draw an angle and you write down the letter of the vertex that you are speaking of. Now, another way to actually name angles is using the 3 points with the vertex in the middle. So right now there are no points on these rays, so let's put one here, label it N, and put another one on the other ray and label that C. So another way to name angles is using the 3 points with the vertex in the middle. So one way to identify this angle would be angle NMC. So notice how the M is in the middle of our angle name. You must include that angle in front so that you know that you're talking and we know that we're talking about an angle. Now the other way is to label or name the angle with going the opposite direction. So instead of NMC, we can go CMN. So angle C, M, and N. Now there are different types of angles in geometry. So there's an angle where the actual angle measure is greater than 0 degrees and less than 90 degrees. So we're talking about like angle measures that are like 1 degree, 2 degrees, 3 degrees, 20 degrees, 50 degrees, 80 degrees, 89 degrees, but it's always less than 90 and always greater than 0. Those are called acute angles. So different acute angles can be, let's say, it looks like this, I guess, and we can say that that's 67 degrees because that's between 0 and 90, that's 35 degrees, and that's 45 degrees. Okay. Another type of angle in geometry is between 90 degrees and 180. So it's greater than 90 and less than 180. Those are called obtuse angles. Okay. So those are a little bigger and wider. They open up a little wider than acute. So they look like this essentially. And these measurements could be 200. That's false. That could be, let's go with, 150 would work, not the other one. Let's delete that. Okay, so it could be 150 degrees, this could be 91 degrees, or 135 degrees. Okay, so those are all measurements that are between 180 and 90. Sorry, I don't know why they put 200 there. And then sometimes there are angles that are exactly 180 degrees, and these angles are actually called straight angles. And what they look like is a straight line, and if you were to measure with your protractor the measurement of that angle, that's 180 degrees. So then finally, an angle measurement that is exactly 90 degrees we call a right angle. And what that looks like is essentially an L, a perfect L. And in geometry, how we know without it saying with a 9 and a 0 that it's 90 degrees, we actually use a box to indicate that it is 90 degrees, and we can identify that as a right angle. So something that I need you to know, or we need you to know in class, is the angle addition postulate. Now a postulate is a statement that is accepted to be true without any proof. Okay, so what you read, you don't have to question it, it's just a statement of fact. So the angle addition postulate states that if you have a point R that lies within angle QTV, then we know that the measurement of angle QTR plus the measurement of angle RTV will equal the measurement of angle QTV. Now that looks like a lot going on. Let's draw it out. So we have our point and our two rays to make an angle. That will be angle QTV. So then we would have point Q on one of the rays, and in the middle would be our vertex T, and then on the other ray our point V. Now it says if R lies within this angle QTV, let's put R in the middle somewhere here. Okay? So we're going to draw a ray from it, a ray to it, from T. So now, if the measurement of angle QTR, so now if you look at it, we have two little angles that were formed because we actually have a point between angle QTV. So we have angle QTR and angle RTV. This angle addition postulate states that the measurement, whatever this measurement is, this angle, if you add QTR, angle QTR, and angle RTV, that will equal the measurement of angle QTV. So let's take a look for at an example real quick. So let's say that the measurement of QTR was 25 degrees. Okay? So then that would be an acute angle. So let's say that the measurement of RTV, which is right here, RTV is 52 degrees. So whatever this angle is, which is 25 in this case, and whatever this angle is, which is 52 in this case, if you add those together, that will make up the measurement of the big angle QTV. Okay? So then if we add those together, if you have 25 plus 52, the measurement of angle QTV would be 77 degrees.